Now we learn how to find out the initial feasible solution of a transportation problem by using the Vogel approximation. Vogel approximation method, in short form it is a VAM, and this method is also known as the unit penalty method. This is known as the unit penalty method because we are finding the penalty each and every table, row penalty and the column penalty. Then we decide the cell for allocation. That's why it is known as the unit penalty method. Now, Vogel approximation unit penalty method is an iterative procedure for computing an initial basic feasible solution of a transportation problem. This method is more effective than the other two methods that we already learned, that is the northwest corner rule and matrix minimum method, or we can call it the least cost method. Or we can call the least cost method. Whatever the initial basic feasible solution we get by the Vogel approximation method, or called the VAM or unit penalty method, that is very near to the optimal solution. When we are finding the optimal solution by using the method, MODI method, then the number of iterations will be more or less in comparison to the another to the method, that is northwest corner rule or matrix minimum method. Now, following steps are involved to finding the initial basic solution, finding initial basic solution by using the Vogel approximation method. First, step 1. First, we have to find out the row penalty. How to find out the row penalty? By using, first we have to find out the minimum and next minimum row wise and find the difference of that. That positive difference is known as the row penalty. So each and every row we have to select and find the minimum and the next minimum, then find the difference of them and take the positive value. This is the penalty of row penalty. Similarly, we have to find out the column wise the column penalty by selecting for each and every column minimum and next minimum difference of the cost, transportation cost, and put it below the column, that is the column penalty. And in the row penalty, we have to put in the right side of the row, that is the penalty column, in the row wise penalty column and column wise penalty column, besides of the available for the row penalty and below the demand of the for the column penalty. Now, the step 3, identify the maximum penalty. Whatever the penalty is there, row penalty and the column penalty, we have to find out the maximum penalty, and corresponding the maximum penalty, we have to find out the least cost. That least cost cell we have to choose for our the allocation. Identify the maximum penalty. If it is along the side, that means if it is the row penalty, then we have to find out the row wise least cost, then start the allocation. If it is below the column, then we have to select the least cost corresponding to that column, then start the allocation from that. Now, sometimes it may be the tie, that means more than one penalty, maximum penalty be the same. That time we can choose arbitrarily any one, but my choice is that which one gives you the least cost, consider the first one, corresponding to the maximum penalty, and which maximum penalty for the case of the tie gives us the least cost. Start with that. In the selected row or column by the step 3 or the step 4, as soon as we got the cell for the allocation by using the step 3 or 4, Then we have to start the allocation. And how to allocate, we already learned, finding the minimum of available and demand, then minusing and put it there. Step 6. As soon as the row or the column which is fully exhausted, in the case of available it is exhausted, and in the case of the demand it is meet our the requirement, then we can block that particular row or column which is completely exhausted. If the column is exhausted, then there is a chances in row penalty and the vice versa. Sometimes maybe the column exhausted, sometimes maybe the row exhausted. From the rest of the row and column, we have to find out the penalty cost. Let us consider an example. Find the initial basic feasible solution of the following transportation problem. Find the initial basic feasible solutions of the following transportation problem by using the Vogel approximation method, or we can call it the penalty method, unit penalty cost method. So this is the given problem where the transportation cost matrix is given. At the same time, the available, that means the supply is given and the demand is there. In this case, cost, this portion is the cost matrix, and these are the available of the supply. Corresponding to the origin 1 is 250, corresponding to the origin 2 is 300, corresponding to origin 3 is 400. And demand corresponding to the destination D1 is 200, corresponding to the D2 is 225, corresponding to the D3 destination is 275, corresponding to the D4 is 250. Now the start solution. During the start solution, you have to check the given transportation problem is balanced or unbalanced. In this case, summation of available, so total available summation AI is equal to 950, and total demand is equal to the 950. So you can write this is summation I is equal to 1 to 3, AI is equal to summation j is equal to 1 to 4, bj is equal to 950. So this is our the balanced transportation problem. Since it is a balanced transportation problem, so we can proceed to find the initial basic feasible solution by using the Vogel's approximation method. We already learned for a necessary and sufficient condition, the existence of the initial basic feasible solution is that total supply or available is equal to total demand. That we already learned. Now for our the computation, this is the first table, that is known as the table 1. In this case, we are finding the penalty. These are the penalty column and these are the penalty row. So this is the table 1 and calculation is the first calculation. That's why it is known as the penalty 1 and this is the penalty 1. This is the column penalty and this is the row penalty. How to calculate the penalty? We already learned minimum and next minimum difference. So in this case, minimum is 11 and next minimum is 13. Difference is the 2. So put it here. In this case, minimum is 10 and next minimum is the 14. So difference is 4. In this case, minimum is 10 and next minimum is 13. Difference is 3. So these 3 is our the row penalty. And column wise, 11 and 16. 11 is the minimum, next minimum 16, difference is the 5. 13 and 18, difference is 5. 13 and 14, difference is 1. 10, both are the minimum. Next minimum is 14, so difference is the 4. Now among them, which one is the maximum penalty? Row and column, both penalties we have to check which one is the maximum, and that we have to put the mark. So these 5 and this 5, in this case both are the maximum penalty, but which one we can take as a consideration? I already say we consider that one which gives the minimum cost. Now see, in this case 5, if we consider this 5, in this column 11 is the minimum cost. If we consider this 5, we get 13 is our the minimum cost. So instead of considering 13, it is better if we consider 11, because if we put here, see how much we can allocate here. Here the 250 is the available, here 200 is our the demand, and here 225 is our demand and 225 is our the available. So if we consider this, if we put here 225, so 225 into 13, and here we are putting 200 into 11, so there will be a cost difference, must be a cost difference. That's why we should consider which one gives us the least cost, consider that one. So let us consider this our cell where to be allocated. 1 and what to be allocated? Minimum of 250 and 200. 250 and 200 is the 200. Now you already learned how to allocate and how much to be left of supply and how much to be left of the our demand. That calculation we already learned. So I am not going through that in details how to calculate the remaining part of that. Now here our demand is met, that means 200 is over. So how much is left? 0. Or which one we are considering? The penalty that we are marking by the arrow. That means it is considered in the first. And since the demand is totally covered, met, and left is 0, so we cover it by a block it by a line. And how much here available is left? 50 after minusing the 200. So this is our first table. So move to the next table. We have to calculate the again penalty P2. P2 considering the rest cell. This cell we have to consider. The remaining the cost cell in the transportation cost matrix. Just we have to consider this part. This is already blocked. It is blocked because it is not come to the consideration wrongly. That's why I blocked that. This is already done in the previous table. Now from the rest of the part, again we have to calculate the penalty. That penalty is now we have to calculate the penalty 2 in the next table. Blocking is showing. Next, again we have to calculate the penalty 2. Now this is the table 2 for calculation of penalty 2 and the calculation. P2. So what is the difference of 13 and 14 is 1. Now this is already exhausted, covered up by the line. Now 13 and 18, that is the again 5. 10 and 14, 4, 10 and 13 difference is the 3. Now, this 5 is now come in consideration because this is our the maximum penalty that we are considering. Now, in this case, this is the what is the minimum cost is there? 30. Minimum cost is 30 in this case. Now, how much is left here? 50, and here how much? 225. So minimum of 50 and 225 is the 50, and we are allocating in the cell 1, 2. After allocating the 50 here, how much left in the available corresponding to the origin 1 is 0, and how much demand is left after taking the 50 unit allocation in the cell 1, 2, 175. Now since the origin 1, that is row 1, have no available, so we can block it by a line. So first column and first row is blocked. That means it is not come in consideration in the further calculation. So this portion is only for our calculation. This portion is our only for the next calculation. Now again we are calculating the penalty 3. Difference of 13 and 14 is 1. Difference of 14 and 10 is 4. 13 and 10 is 3. 14 and 13 difference is 1. 10, 10, both are the minimum, 10 same. So next minimum is 14, difference is 4. And in this case, 18, this is already just blocked in the previous table, this one. So how much is left? 18 and 24, that difference is the 6. So among them, which one is the maximum? Which one is the maximum out of this? 1, 4, 3 and 6, 1, 4. 6 is the maximum. So we are considering the column D2 corresponding to the destination 2. Again, we have to find out where is the least cost. 6 is our the maximum penalty. 6 is our the maximum penalty, and considering with that, this is the D2 is our the column, and from that you have to find out 24 and 18. 18 is the less, so we have to allocate in the cell 2, 2 is our the cell where we have to allocate, and how much we can allocate here, that we have to check. How much is demand is there? 175, and how much available is that? 300. So minimum of 300 and 175, it should be the change. 300 should be the first and 175 should be the next one. 300 should be here and 175 should be here, and minimum is there the 175. So 175 we can allocate in the cell 2, 2, where is the transportation cost is the 18. So after allocating the 175, demand becomes 0. And after allocating 175 in the cell 2, 2, how much available corresponding to the origin 2 is 125. Again, we have to find out the penalty considering the rest portion of that. And again, we have to choose the cell where to be allocated by considering the maximum penalty. Now see, this is the fourth table, penalty 4 we are calculating. this much is left only. So 14 minus 10 is the 4. 13 minus 10 is equal to 3. And here no one option 10 minus 10 is 0. Here 14 minus 13 is equal to 1. 14 minus 13 is equal to 1. So in this case, maximum penalty is out of 4, 1034. 4 is the maximum penalty. So in this stage, we are considering the 4. In this stage, we are considering the 4. And where is the minimum cost? 10 and 14. 10 is the minimum. So where the corresponding cell for allocation is 2, 4. Where we can allocate now. This is the cell where to be allocated. And how much to be allocated? How much is available is that? How much is available is that? 125. And demand is 250. So minimum of 125 and 250 is 125. So we can allocate here the 125. So how much is left? 125 minus 125 is 0. That means origin 2, that means the second row again exhausted and blocked by a line. And after taking the 125, demand is left again the 125 unit. So next table we have to calculate the P5. Again we have to choose the maximum penalty. Then we have to select the cell and we have to allocate the allocation. Now see, this is already blocked. Only left this cell. Only left this. This should be the 10. 13 minus 0, that is the 13, and 10. This should be the 10. This should be the 10. So 10, 10 is 10. And here 13 minus 10 is the 3. And 13 is here. Because there is no minimum is there. So it would be here. What is the cost is that? That should become here. What is the cost is that? That should become here. And what is the cost is there? That is the 13 minus 10 is equal to 3. So out of this, which one is the maximum? 13 is the maximum. 13 is the maximum. So we have to allocate in this column. And where to be allocate? Here. Because this cell only the left. So as how much to be allocate here? 400 is available and 275 is demand is there still. So 275 and 400 minimum is 400 comma 275 is the 275. So we can allocate here the 275. 275 after allocation, what we will get? 400 minus 275 we will get the 125. And after allocating the 275, demand becomes 0. 275 is exhausted. So after exhausting, it should be cross out. And how much is left? 0 will be left. We should cross out the 275 and we have to put it here the 0. Now, then we left only the demand 125 and available 125, and that is only one cell is there. So that we have to allocate here in the next table. 400, this should be the 275. This should be the 275 and 275. This should be the 275 and 275. Now see here, the minimum is 275 and 400. 400 and 275 is our the 275. After allocating the 275, how much is left here? 125. And it is totally exhausted. How much is left? 0. So after calculating the penalty 5, we got the 5 allocations. The rest is pending here, the one cell. And how much is demand is till now is there 125, and how much the available is that 125, that we can allocate here without calculating this. So rest the cell is only one, is the 3-4, where we can allocate the 125, because the hour available is 125 and demand is 125. So it is completely exhausted our available and we meet the demand, and demand is left is equal to 0, and our allocation is complete, because though no here the available is pending, all the available is becomes in this table is 0, and all the demand becomes 0 in this table. So this is our the computational final table for a Vogel's approximation method. Now you have to check the our initial basic feasible solution. These are the basic feasible solution is degenerate and non-degenerate. How many basic feasible solution is there? 1, 2, 3, 4, 5, 6. This is the number of allocations is capital N is equal to 6. And here our origin is the 3 and destination is 4. So m plus n minus 1 is equal to also the 6. So we can say this is our the non-degenerate initial basic feasible solution. Since all the available AI and the requirement BI are exhausted in, so this is the final table that already I discussed. Now, what are the initial basic feasible solution? X11 is equal to 200, X12 is equal to 50, X22 is equal to 175, X24 is equal to 125, X33 is equal to 275, X34 is equal to 125. So this is our the initial basic feasible solution. X11 is equal to 200, X12 is equal to 50, X22 is equal to 175, X24 is equal to 125, X33 is equal to 275, X34 is equal to 125, and remaining Xij is equal to 0. The total transportation cost is equal to cost that cell into 200, cost that cell 13 into 50, cost that cell 18 into 175, that means 125, that is 24, that is C24 is equal to 10 into 125, then 13 into 275, that is the C33, C33 is equal to 13 into 275, 34, C34 is the 10 into 125 unit is equal to 12075 unit. So this is our the transportation cost we got by using the Vogel approximation method. Now, after completion of these 3 methods, we should learn the how to find out the optimal solution. This is the optimal or not, that by using the Modi method.